All right, today we want to take a look at how to solve equations with radicals, or with fractional exponents. Fractional exponents would also could be written as radicals, so this would apply to those. We have 4 steps for solving equations with radicals. The first one is to isolate the radical. In other words, get it on one side by itself. Okay, on one side by itself, nothing else with it. After that, we're going to raise both sides of an equation to a power that will cancel the radical. We might see why this first step is so important when we want to cancel the radical. After that, we should be left without a radical at all, a square root, a cube root, whatever root we have. So we're going to solve just like we normally would, and we're going to check all of our solutions. Now this last step is a pretty common one in algebra, but often overlooked. It becomes very important as we start solving radicals, and the reason is extraneous solutions. Extraneous solutions are extra solutions that can occur, especially when you are multiplying both sides of an equation by a variable. If you multiply by a variable, it's possible that you are adding in solutions that aren't really there. So we want to look for our extraneous solutions as we are going through these steps in the checking phase. Okay, so we're going to check everything at the end. Which means we are now ready to solve an equation. Let's go solving an equation. We are going to solve this fourth root equation, and we're going to do that by first isolating our variable. We're going to get a 7 on the other side and leave this as a fourth root of 48x minus 7 equals our 3. And you can see now we're going to raise both sides to the fourth power. The fourth power is what would cancel out a fourth root. Okay. Now you might see it done here. You may also see occasionally people would prefer, and it doesn't matter to me which way you want to approach this, to write this in exponential form first. Raise this to a 1/4 power equals a third. Remember, fractional exponents equivalent to radicals with the same index. And you can see now perhaps how raising to the 4th power, these two powers, well, raise both sides to the 4th power, are going to multiply together and become a 1. And that's what's going to leave us with the simple 48x minus a 7 equals an 81. 3 to the 4th power, 81. And when we add our 7 then to both sides, we can start to get a feel for what x is going to be in this case. Looks to me like it will be a fraction. Both 88 and 48 divisible by 8. So let's reduce that by an 8 and we'll get an 11/6 as our solution. Now, we said we were going to check that. So let's go check that. Let's take our 11/6. Let's take and put that into the fourth root of 48 over, I'm sorry, not 48 over, 48 times 11/6, I suppose we could put it over 1, minus a 7, all plus a 7, and we're hoping that equals a 10. Let's find out what it does equal. We'll cancel maybe our 48 and our 6, leave behind an 8. We now have a fourth root of 88 minus 7 plus a 7. Fourth root of an 81 plus a 7. Fourth root of 81 is a 3 plus a 7 is our 10. It does check out and equal out the way it was supposed to be. Very important to check for extraneous solutions. You're going to find that perhaps in some of these more simplified versions that you're starting off with in this lesson, that you won't come up with too many, but as you go on and deal with more complicated square root problems, you will find more extraneous solutions. I hope this helps.